Hey guys, this is Mr. Bonifaci. I'm going to go over with you guys how to do stoichiometry calculations. Specifically, I'm going to teach you guys, we'll do a brief review of how to do mole to mole conversions. And then we'll also go over, and this might be a little more advanced for some of you guys, mass mole conversions, where you either go from the mass to moles or moles to mass. So we'll cover both those in that kind of order. Okay, it's going to go decently quick here. First thing I'm going to share with you here is I'm going to share with you the notes you should really write down. Okay, so this is all of the stuff. If you write down the stuff in bold, okay, that is the stuff that we'll be using. The rest of it's good too, okay, but the stuff in bold is the stuff that right here. So mole to mole, and I'm going to repeat this later when we get to that part, is you divide by the amount of mole by the coefficient above it, and then you multiply by the coefficient of the moles you're calculating, which is the goal, okay? In grams to moles, you divide by molar mass, and moles to grams, you multiply by molar mass. So that's how that is. So I'm going to move on, but you should go ahead and pause and write this down if you haven't had a chance to do that yet, okay? So the first problem we're going to be doing here is from, and I'm going to go ahead and start doing a camera where you're going to see my work here. Let's see here. I'm going to zoom in a little bit. That'll work. Okay, so we're going to go ahead and start with part 2 here. Okay, and you'll notice that sulfur is going to react with sulfuric acid, which is H2SO4. Okay. And when those two react, it forms sulfur dioxide. So you need the arrow here. Okay. And sulfur dioxide. And then it's also going to form water. Okay. So the first step you always do, if you look at those notes that I didn't make you write down, was to balance it. So counting here, I have 1, 2 sulfurs. I only have 1 sulfur, so I put a 2 here, give me 2 sulfurs. Okay. Over here, I have 2 H's, that's balanced, 4 O's. Now it looks like at first you have 4 O's, 2 times 2, 4, but you have to fit the O here. So we need more. Now you could try to just do it in your head, but I honestly, sometimes the easiest thing to do is just go to add 1 more of the big guy and just move forward and see what happens. So we'll put a 2 here. Let's go back to S's. We now have 3 S's. So that means we have to change this to a 3. So that is my not so attractive 3 there. So 3, okay. So 1, 2, 3 S's, 3 S's, 4 H's. So I need to put a 2 in front of here to get 4 H's. For O's is 2 times 4 is 8 O's. On this side, we have 3 times 2, which is 6, plus 2 times 1, which is 2. So 6 plus 2 is 8. So 8 O's, balanced. Okay. So now, in that way, I'm sorry, it's in the small corner of your screen here. It's not the best way to do this. We're going to go ahead and we'll go ahead here and write down the materials and how they should go. Okay, so if we read question A here, it says if you have, well, first thing I'll say is you're going to put moles down here and you'll label this A, just so we know that's A. Okay, so we put A in moles. Okay. And we'll zoom in on this in a second, okay? If you have 3.2 moles of sulfur, so you look across the thing, where's sulfur? Now, I'm not talking about sulfur in sulfuric acid or sulfur and sulfur dioxide. Just sulfur itself is right here. And this is 3.2, so I put the 3.2 here. It says you have excess of sulfuric acid. You could write the word excess in here if you want to. It means you have more than enough, or you could just ignore it, okay? It just means you have plenty. So you have this amount of this and more than enough of that. Okay, and you want to know how many moles of sulfur dioxide would be formed. So you put the circle wherever you want to go to. So it says sulfur dioxide, so I put a circle there. Okay, so in this way here, making sure everything's centered. Okay, so you have 3.2 here under sulfur. You get excess of this, and you put the circle of where our answer is. So how do you get to our moles sulfur dioxide? Okay, well, we follow that first step of moles to moles. You divide by the coefficient above, so you take your starting number, 3.2, and you divide by the coefficient, which is 1, and you multiply by the coefficient where you're going to, which is 3. So you're going to end up with an answer that's like 9.6, I think it is in your head, in my head, okay? So, which makes sense. If you need 1 of these, you'll get 3 of those, okay? So if you have 3.2 of those, you'll get 3 times more of that. So that makes logical sense. So then we move on to B, and we label it moles, okay? And we're going to, again, use this as a chart, okay? So anything below here is sulfur, anything below here is sulfuric acid, and so on, okay? I'll go share the screen really quick so we can get that information written down, and we'll go ahead and do B here, okay? So if you need to produce 6.34 times 10 to the 2 moles of water, so that should go under water, 6.34 times 10 to the 2. How many moles of sulfur and sulfuric acid do you need? So it wants this and this. Okay, it wants both those. Okay, so how do we get there? Okay, well, again, you're going to take this number and you divide by the coefficient above it. So you divide by 2. And if we're going to this one, we then multiply by 2 because that's the coefficient where we're going. Now, I just know out of my head is 6.34 times 10 to the 2. And you're like, I didn't even use the calculator. The reason is because when you divide by 2 and then you multiply by 2, they cancel out. So you get the same exact answer. That would not apply to this, though. So you have to divide this by 2 and multiply by 1. So I think you get 3.17 times 10 to the 2. Cannot forget the exponent. Okay, cannot forget the exponent. So that's how you do mole to mole conversion. So hopefully that felt pretty good. I'll go ahead and draw a line here so we know we're going to the next thing. And we're going to go ahead and talk about how do we do ones that involve mass too. Okay, so as a quick reminder, remember the mass ones, if you're going from grams to moles, you'll divide by molar mass. And if you're going moles to grams, you'll multiply by molar mass. Okay. So here are the problems we're going to be doing. 1 second. Here, I should have been sharing my screen. Oops. Sorry about that. I'll go back to that. So if you are going from grams to moles, you'll divide by molar mass. If you're going from moles to grams, you'll multiply by molar mass. So I'm going to go over here and find our practice problems. So the first thing it does is it gives us an equation, AgNO3 plus NiCl2 goes to AgCl plus NiNO3(2). Okay. So the first thing I'm going to point out is if you ask yourself what type of reaction this is, you'll realize it's a double displacement. Ag is of NO3 and Ag ends up with Cl. Ni is with Cl and ends up with NO3. So swapping partners. In that case there, you can treat the NO3 as 1 unit. Okay. So you have 1 Ag, 1 Ag. That checks out. You have 1 NO3 and 2 NO3. That does not check out. So you're going to need to put a 2 in front of here to balance that. Now that throws off our Ag. So we need a 2 here to get 2 Ags also. Okay, so we have 2 Ags, 2 Ags, 2 NO3s, 2 NO3s, 1 Ni, that's still right, 2 Cls, 2 Cl. So we just balanced it, okay? And we can again treat NO3, which is a polyatomic ion, as a whole unit in any type of displacement problem, double displacement or single displacement, also called double substitution or single substitution. So. Okay, back to our actual problem here. Okay, because, actually, first, before I share the screen, how do you set up something with mass slightly differently? Well, this will be problem A, so I'll put A there. You're going to need to put moles, and then you're going to need to put grams below it. So the second level where you put grams there. Okay, so I'm going to go ahead and share our screen here, and we'll see how this plays out. Oh, I guess it's 1, not A. It's 1. Okay. So if you have 32.9 grams of nickel 2 chloride, so this is nickel 2 chloride, okay, and it says, and I should put in the grams column because it's giving me a grams, 32.9, okay, and excess silver, so this is all excess silver, and you can put it in, it's excess in either one, or you can just leave it alone and not put it down, that's fine, you just have plenty of silver. nitrate there. How many moles of silver chloride will be formed? So you're asking about silver chloride, and it's asking moles of silver chloride. So that means you're going to here. So notice that moles are on top. So I start over grams. Okay. The way this flows is you're going to go up and then you're going to go across, because you can go from grams to moles, and then you can go from moles to any other moles. Okay. So we're going to go in that kind of order here. Okay. So how do you get there? Okay. So, well, you need to know the mass of nickel 2 chloride. So I can go ahead and add that up really quickly. So 1 second here and grab my periodic table. Quickest way to do it. Is using, add up really quick. 1 second. Table. There it is. Nickel 2 chloride, 35.45 times 2 plus the mass of nickel, which is 58.69. Okay, so I like to label this at the top so I can reuse it. So right here, nickel 2 chloride, right here, I'll go label it. It weighed 129.59. Okay, so now I have that for any problem going forward, which I might need again. Okay, so I'm going to go ahead here, and again, when you go from grams to moles, you divide. So I go 32.9 divided by 129.59, and my answer is, and I need at least 3 sig figs here, is 0.25, and let's say I round up to a 4. Okay, you need to show your numbers along the way. You can't leave this blank. I normally won't put arrows in here. I'm just kind of doing this as a flow to kind of show the way I got there. Now, how do I go from here to here? Well, moles to moles, remember, I divide by the coefficient above, and I multiply by the coefficient where I'm going. So it's just a matter of multiplying this times 2. And it looks like I end up with 0.508. 0.508. And there you go. Boom, one done. Let's go ahead and do a second one here. Okay. Now, number 2, again, we're just using the same chart of moles and grams. I'll go ahead and share a screen. I should have actually stopped sharing screen. I apologize for that. I will definitely make sure to do that this time. Sorry about that. I got distracted by not knowing the mass. Okay. So if you have 8.2 grams of silver nitrate, silver nitrate is right here. So, and I have 8.12 grams, 8.12 grams. Okay. And excess nickel 2 chloride, right? Nickel 2 chloride. So I have excess of this stuff this time. Excess. Tons of excess over here. Okay, good. How many grams of silver chloride? Well, so I want grams of silver chloride being formed here this time. So grams of silver chloride. So that's the bottom one. So notice we start with grams here. We're going to go up to moles, and then we'll go from moles to those moles. Okay, that's kind of our flow. Okay, so in this case here, I need to know a few different masses. I need to know the mass of this guy, and I need to know the mass of this guy. Okay, so let's go ahead and do that. I'll just go O, which is 16 times 3 to get this one here. Then I need to add an N to it. N is 14.007. And then I have to add an AG, which is 107.87, I believe. Yep. And I end up with, and I like to label it at the top here so I can reuse it, 169.877. Okay, there we got that. And then we'll go ahead and figure out the mass of this one right here too. So in that way here, AG again is 107.87 for AG, double checking that. And then it's with a CL, I believe, right? AG and CL, which is 35.45. 107.87 plus 35.45 is, and this one here is 143.32. Okay. I'm going to stop sharing so you guys can see better. Okay, so I've labeled, I have the starting mass. I figured out the molar mass here. I'm going to go, that's my alarm, sorry about that. And go for, I'm going to go up here to moles. Okay. And then I can use my mole to mole ratios to get to here. And then I'll use my molar mass to get back. So again, the way you go from grams to moles is you divide by molar mass. So let's go ahead and try it. 8.12 divided by, and I enter the 169 number, 169.887. Okay, equals, and I have to enter every number along the way. I need 3 sig figs, so 0.0478 if I round to 3 sig figs. If you have extras, it doesn't hurt, but don't have less, please. How do I go from moles to moles? Well, you divide by the coefficient above, so I divide it by 2. And then I'm going over here, so I multiply by 2. So divide by 2, multiply by 2, so it's the same number. Yay, so 0.0478, that's a 4. So same number as the other side right there. How do I get down? How do I get down into grams? Well, I multiply times the molar mass. So I go times 143.32. And it looks like my answer here is 6.85. 6.85. Okay. So, and then that's how you get to your answer there. So you started with 8 grams of this, you reacted it, the mole conversion happened, and only 6.85 grams of silver chloride formed. Okay. I'm gonna do number 3 if you want to watch. If you totally get it, you don't have to. Okay. So let's do number 3 here. I'll go ahead and share the screen here. Okay. So it looks like here again, you have to do moles and grams again. Okay. And it's going to be, can I get them all on the same screen? A little bit. Okay. It's going to be a little more challenging. Okay, let's zoom out a little bit. There we go. That's a little bit better. Okay. So it looks like I start with 234 grams are formed of nickel 2 nitrate. So that's this one down here. Nickel 2 nitrate grams. Actually, I don't think I'm going to do that because I don't want to add that up, but I'm going to show you how to do it, and then you can solve it yourself. So 234.8 grams. Okay, that lines up perfect. Are formed. How many grams of each reactant were used? So I need to figure out how many grams of this reactant and grams of that reactant. Okay. So I'm going to go ahead and I'm just going to kind of talk you through it. I'm not going to work to the answer because I don't want you guys to have to watch me add this guy up because that'll take a while, and I just don't want to. I don't want to put you through that. Okay, so how will you do this? Well, you'll first start by finding out the mass of this one. We found the masses for all the others, but not this one yet. You'll need to find the mass of this one. So you'll find the mass of this one, and then you're going to take this, the 234, and divide by the molar mass of this guy. Okay, and that'll give you your answer there. Once you have that, you can go mole to mole. You can go mole to mole here. This is a 1. Okay. So when you go to here to 1, so whatever this number is, it's going to be the same as this number here. Okay. It's going to be the same as that number there because this is a 1 and this is a 1. Okay. When you go from this one to this one, you'll divide by 1, right? And then you'll multiply by 2. So this number right here is going to be double whatever this one is. Okay. And then how do you get from here down there and down there? Well, you take this number and you multiply times the molar mass, and you take this number and you multiply by the molar mass. And then that would get you your final answers, which would be nice and neatly circled. So hopefully that helped out. Thank you guys very much. So have a nice day.